Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my Absolute Beginner Guide, the video series I'm putting together that has a special focus on people who are brand new to Orbiter. In this section of the Absolute Beginner Guide, we're spending a lot of time trying to learn how to use TransX. In the last several videos, we started off by going from the Earth out to the Moon. I think we did that a couple of times. And then we did a return trip. We learned how to use TransX to go from the Moon back to the Earth. Now, it is very important that you have seen those videos so that you have the base familiarity with TransX. We're now going to start learning how to go to the other planets using TransX. But if you don't already have that fundamental understanding of how to navigate TransX, then this is going to be too difficult for you. I'm making this video with the assumption that you have watched those other videos. So if you just tune into this one, and you might not be able to follow along because I'm going, again, I'm assuming you saw the other videos, so I'm not going to explain things in the level of depth that I did when we did those other videos. So we're going to learn how to go to Mars, and yeah, let's go ahead and get started. Let me switch camera views here. And once again, we are using the XR2 Ravenstar. As I stated in one of the previous videos, once you get to a certain level of comfort with Orbiter, you're probably going to find that the standard Delta glider doesn't really meet your space flight fantasy needs. It's a great vessel, but because it doesn't have locks, because it doesn't have APU and these types of things, the simulation can kind of feel a little generic. So the XR2 helps us spice things up a little bit. Now, speaking of the XR2, now if you want to do this with the Delta glider, by the way, that's absolutely fine. You can use the standard Delta glider and you can follow along with this and you'll have no problem. Just when we talk about turning on the APU and doing things like that, then you can just ignore those parts. But one thing to note about the XR2, and this would also apply to the XR5 and other vessels that have locks, is that the default configuration, and that's what we're going to use here. We're not going to get into any kind of fancy, expert mode configurations because this is the absolute beginner guide. But the default configuration, if I press Control down arrow, you'll notice that it only has 14 days of locks. And obviously we cannot get to Mars in 14 days, at least not in any sense of that's realistic. So one of the first things we want to do, or one of the first things we want to make a note of, is that we are going to require more locks than that. So just keep that in the back of your mind. And once we get into the actual setup of going to Mars, then we'll determine how much locks we need to carry. But just right from the start, know that you don't want to take off with only 14 days. Okay, now let's go ahead and switch cockpit views over to the larger MFDs. And we're going to bring up TransX on both sides like we usually do. And one thing I'll mention is that, and Dimitri kind of pointed this out to me, whenever we plan a flight, we almost always actually start the planning in the middle and then do that, and then do that part, do kind of from the middle forward, and then we go back and figure out how to plan the first part. I never really gave that a lot of consideration when I'm just going straight from Earth to Mars, but that's exactly what you do. So the first part of the plan that we're going to set up is assuming that we're already in orbit around the Earth. And then we're going to figure out how do we go from Earth orbit. Technically, actually, I should say it's if we're in orbit around the sun at Earth's position, but that's kind of a technicality. But basically, how do we go from that position to Mars? Once we know that, then we can figure out how to get up off the ground where we're at. So we're obviously not in orbit around the Earth. We're sitting here on the ground. But once we figure out how to go from Earth orbit to Mars, then we can back up and figure out how we go from the ground to Earth orbit. Now, again, we're going to move through things without a ton of hand-holding here because I spent a lot of time on those last Earth to Moon and Moon to Earth videos. So let's just go through this. Stage 1, you should be familiar with what TransX looks like when we're sitting here on the ground on a given body. And just briefly, The gray circle that you see is Earth, and if we compare quickly to orbit MFD, we have the same radius, that's 6.371. You see that given here, and the inclination is the same. All the stuff that we talked about before. So the default view of TransX is is very similar to what you would see in orbit MFD. Now, to set up a flight to Mars, we need to actually escape Earth. So we're going to go plus plus, and then we're going to go to escape. So that's like step one, is to in stage one view setup, set your target to escape. Now you don't target Mars from Earth. Like when we're going to the moon, we actually target the moon directly from Earth, and that's because the moon is actually in orbit around the Earth. But Mars is not in orbit around the Earth. Mars is in orbit around the sun. So we actually need to escape Earth completely. We need to get completely away from Earth's gravitational pull. So that's why we choose escape. Now we're going to go forward on this side, and we now have the view that we're now looking at. This plus here in the center is the sun. You can see the major bodies of the sun. And then this is now the orbital path of the Earth around the sun. So kind of similar to what we saw when we were sitting there on the moon. We saw the Earth in the middle. We saw the moon orbiting around the Earth. Pretty similar to what we had there. But now we can choose our target, because this stage now says, we've escaped the Earth from the previous stage. Now we can actually target where we're wanting to go, and that's going to be Mars. And you just hit plus plus or minus minus until you get the correct body, and it looks like plus is going to be the fastest way to get there. If we went minus, we would go backwards through a whole lot of places. So now what we're looking at is the orbit, or rather the sun here in the center. That's still the same. Now this is the orbit of the Earth around the sun, and this outer ring is the orbit of Mars around the sun. Okay, so that's what we're looking at now. So once we have that selected, we're going to press VW to get over to the eject plan. And now, since we're going out away from the Earth, we're going out away from the sun, we need to increase the size of our orbit. We need to raise one side of our orbit, so to speak. Whereas when we were coming back to Earth from the moon, we needed to lower one side of our orbit. So if we did that here, if we put in negative prograde like we did when we were coming back to the Earth from the moon, you can see it's lowering our orbit. This is our hypothetical orbit. It's getting farther away from Mars, and obviously that's not what we want. So let's go to rough here, and we'll just put in enough prograde velocity to raise our orbital path all the way out to that of Mars. Now this is saying that if we leave Earth here in the next hour or something, we're going to do a maneuver, a burn, and it's going to take us out here along this hypothetical path out to the orbit of Mars. But there's a problem. We are going to get to Mars is actually going to be at this point, and when Mars is at that point, we are going to be over here. So we're going to be missing Mars by 142.9 gigameters, and off the top of my head I don't even know what that translates into, but it's like 142 billion kilometers or something. So clearly that solution is not going to work. And what that basically boils down to is timing. We have I'm recording this video Tuesday, April 8th, 2014, and this date is not a good date to fly to Mars. This is one of the things that makes going to the planets a little bit more inconvenient than simply going back and forth between the Earth and the Moon. When you go back and forth between the Earth and the Moon, you can do that on any day. You don't have to plan for it necessarily unless you get into some more sophisticated flights. But generally speaking, you can go back and forth between the Earth and the Moon anytime you want. So what we have to do now is we have to find a time, a date, maybe a month from now or 5 months from now or a year from now, we don't know. But we need to find a date that will work, that will allow us to leave Earth, go out to Mars, go out to the orbit of Mars, and arrive at the same time that Mars is passing that point in its orbit. Now, I'm assuming you've also seen the How to Fix TransX video, and you have the latest and greatest TransX. If you have the latest and greatest TransX, we have a much easier and faster way to solve this problem by using something that Enjo created called AutoMin. And basically what it does is it finds the amount of prograde and the amount of outward and plane change if necessary that we will need, and it'll find those values automatically, hence the name auto min. And I believe the min just stands for minimization, like find the automatic minimal value that's necessary to get us to that point. So the easiest thing to do, and what I would recommend for absolute beginners, instead of trying to adjust these values manually like this, where we're going to say, well, we need this much prograde, and we're going to come over here to the outward, and we're going to put in a bunch of outward. You can see the closest approach is coming down. That's one way to do it, but a better way, the preferred way, let me reset this, with the newer version of TransX is to set your value. Let's start with prograde, and let's set it to the auto min. So we're going to say plus there. And now what we're going to do is we're just going to change the date value. For now, we're going to leave outward, and we're going to leave plane change on 0. But for now, we just want to set the prograde, and we want to start adjusting the date value to find a time when we can leave Earth and arrive at Mars with a reasonable amount of delta V and in a reasonable amount of the time of flight. TOF stands for time of flight. This is how long it's going to take us to go from Earth orbit to Mars. So go to, it usually helps if you start on the rough setting, because we need to adjust the date by several weeks and several months in many cases. So start with a rough adjustment, and just you probably want to go forward. You can go backwards and find a date that worked in the past, but typically I like to go forward. If you do prefer to go backwards, that's fine. You can use the scenario editor and change your time so that it's in the past, but I like to go forward. So I'm going to go forward. And what I'm looking for here, number one, we need the closest approach to be obviously down, very low. And as a matter of point, right now, in fact, let me actually just find this lowest point real quick so I can. So let's back up a little bit more even. Get all the way down to the very, very lowest. So right here, in fact, let's do a bit more an adjustment. So if we go forward on this side, we can see, if we look at the encounter, that we are actually hitting Mars on this launch date, which is 56742, which is actually just a few days ago. And we could do that if we wanted to, but one thing you want to look at is notice how this hypothetical line goes out into space way beyond the orbit of Mars. Then it comes back in. That's a really inefficient way to get to Mars. That means we're using more fuel than we need to go to Mars in the first place. And then when we start to fall back in, our encounter velocity at Mars is going to be higher than it needs to be. What we really want to see this hypothetical line look like is this. Let me back up a little bit. Actually, let me just go forward until I find one that looks right, and then you'll be able to see the difference. But as soon as I see something that looks good, I'll stop and just let you know. But here you can see now the distance between where we would be here and where Mars is at is way off, so this date clearly isn't going to work. So we're just going to continue going forward until we find a time where things start to line up a little bit better. Just continuing to go forward. And also, here's kind of what I'm talking about. Notice how this hypothetical line now comes out here, and it's not quite touching Mars. That's more along the lines of what we want to see. Now it's just barely touching the orbit of Mars. So we're getting pretty close to what may be a solution. So let's go to the outward variable, and let's set it to automatic. Let's set it to automatic as well, and let's set the plane change to automatic. Now back to the date, and we don't want to do a rough at this point because we think we're getting somewhat close to what might be a solution. So let's go down to a medium setting and start using it that way. As soon as you press plus, plus, or minus, minus, now the other variables start kicking in, and this one's actually maxed out, so we might have to do another adjustment there. But we're just going to continue going forward. Notice the closest approach is coming down. And we'll just go forward. And this may work, it may not, we'll see. Go ahead and go to a course setting. Just go forward a little bit more. And I mean, this is okay. I don't really like it that much because we are going out farther into space than we really need to. But for the absolute beginner who just kind of wants to get things done, then we can probably go ahead and take this solution. Let's go ahead and do an adjustment down to a medium setting, and now let's just watch the closest approach. Okay, that's there. We're there. When you see the number down that low, you can see now we're right there at Mars. So sorry about my chair squeaking so much. I really need to get a new one. Okay, now the closest approach is all the way down to 269 kilometers above the center of Mars, which means we're driving more or less straight into the center of it. But in terms of efficiency, I wouldn't take this flight myself normally, because you can see down here the total delta V cost for this flight is 3.5, so 3,500 meters per second. And I know from experience that this is high. We can beat that by quite a bit. But for the sake of the absolute beginner guide, I think it's best just to kind of take the first solution that we find that works. So this is what we'll go with. Now, the next thing we want to do before we do anything else is make a note of this date, and it's 57418. And we want to use the scenario editor to move the date close to that number. So let's do that. We don't want to use time warp because it's way too far out in the future. It'll take forever to time warp. So go to the scenario editor and then date and put in that number, but subtract 1 day from it. And I'll get into explaining a little bit about that in a moment. But we want 57417.5, and you don't have to worry about the last decimal points. Then done and close. And I apparently forgot to apply it, so let's try that again. Scenario editor, date, 57417.5, apply. I think I hit now or something. Then done, close. And now you'll note that the closest approach went from 245K up to 90,000 kilometers. And that always happens when you move the date forward by a lot. And that's exactly what we just did. But with the auto minimization turned on, we've still got outward set to auto min, we've got plane change set to auto min, and prograde set to auto min. All we have to do to fix this is just bump the date forward and backward by like just a fraction. It's all the way down to the super setting. That's fine. If we wanted to, we could even go to ultra. And watch what happens just with one click. It went from 90 to, actually it went up. So let's try it a little bit more. So auto minimization just needs to find a, let me go back to fine. It needs to work out the algorithm a little bit more. Every time you press plus and minus, that algorithm reruns. And it looks like we need to just go forward a bit more. But it's not changing our date by a lot. You notice we're 57417, and we're just moving it forward by about 24 hours. But we do want to get down to where that closest approach is just, a very, very low number. Unfortunately, it seems to be, actually it's not increasing our delta V. I thought it was. And there we have it. Now we're hitting Mars again because this number, anytime that number is below 3M, that means you're actually, about 3M, that means you're actually hitting Mars, because the radius of Mars is only like 3,000 kilometers. Okay, so there we are. We're right back down into the middle. Now we did move the date forward. Instead of 24 hours, it's a few days. So let's use the scenario editor and get closer to this date. And again, we'll just go 1 day prior to that. So 57422, and we don't even need to worry about those decimal points. Apply, and done. And now, since we only moved the date forward by 4 or 5 days, it didn't really change our closest approach at all, so we don't need to worry about, editing this part anymore. Okay, now we have figured out how to go from low Earth orbit to Mars, but we still have not yet solved the problem of how to go from where we're at right now, which is sitting on the runway at KSC, into low Earth orbit. But the reason we have to figure out this part first is because this part determines how we're going to get into orbit. More specifically, it determines the launch heading. do we take off and fly at 90 degrees, or do we take off and fly at 43 degrees or some other number? We don't know what launch heading we need until we figure this part out. So that's kind of why we start the planning in the middle and work forward and then come back to the beginning and figure that out. Now, one other point, time of flight. It's going to take us 179.5 days, so let's say 180 days, to go from low Earth orbit out to Mars. And remember, one of the first things we talked about was that we only have 14 days of LOX in the default XR2. So what we need to do here is we need to go up. So from this panel, press Control Up arrow, and then go to the payload camera view. Hopefully that shows up in the playback. And click, the easiest thing to do is to click the payload editor over here. And that brings this up. And there's a way that you can add this to your simulation where you can actually like drive a truck over to your XR2 and unload an XR2, a LOX module, and then have the grapple pick it up. But I don't really care for that kind of stuff. It's too much busy work. So for the LOX, come down here and we'll start by selecting an XR2 payload LOX half. We'll see if that's enough. If it's enough, then there's no point in carrying a full LOX. So let's choose half and then click on either 2 or 3. It usually makes more sense to put it in number 2 just for center of gravity purposes, although the XR2 doesn't model that. But if it ever did, then it would make more sense to put it closer to the center of the ship instead of closer to the engines. So now we have a half LOX module in payload number 2. Let's see how much LOX that gives us. So control down arrow, that gives us 217 days. And how long was our time of flight? Let's check that. It was 179.5, about 180. So with this amount of LOX, we have, 20, almost, that's 37 days to spare. That's quite a bit of, that's plenty of excess. We certainly don't need any more than that. So we don't want to carry a full LOX module. Let's see though what would happen if we said that we did want to carry a full LOX module. So let's go XR2 payload LOX and click that. So if we're carrying a full LOX module, we're going to have 420 days, and that's like 240 days of waste. That's a whole lot of mass to carry for no reason, so let's definitely not do that. So let's get rid of that and go to the half LOX, put that in. Now, one other thing I like to do, I wouldn't necessarily recommend it for the absolute beginner, but you can do this. Notice this larger cargo bay slot here. We can't put LOX in that, and we can't put main fuel in there, but we can put something in there called the Crew Habitat Module, or CHM. So if you come down here and click on the XR2 payload CHM, and then put that there in number 1, this has no functionality at all, nothing. It doesn't do anything. All it does is add mass to your vessel. Look over here at the ship's mass in kg. When I take this out, notice that the mass dropped by, 4,000 kg. And when I put it back in, we go from 40, whatever the number is, to 44. So it's a pretty heavy object to put in. The theory, the idea of the Crew Habitat Module is that it's basically living quarters or maybe science experiments or things like that for the crew. It's more realistic to carry it, but it does add more mass to the vessel, which means you're going to burn more fuel. So for the absolute beginner, if you don't want to carry it, you don't have to. Just don't include it, and your vessel will be lighter, and you won't burn as much fuel. And it kind of makes certain things a little bit easier overall. But when you get to a certain level of proficiency, for the sake of realism, you're going to want to always include the CHM, and I'm going to include it in my flight because I've got plenty of time in the XR2. Finally, if we want to see what the load looks like, we can come up to that payload camera view, and we can quickly open the payload doors, turn the APU on because it's a moving part, and use a little bit of time warp to speed that up. And take a look at the external view, and that's what we're carrying. We're carrying that LOX module. Now, this LOX module is the same physical size as the other LOX module, but it's just half full. You know, it's like if you measured it, like if you had liquid in here, it would only come to the center point. And then this is the crew habitat module. This just gives the crew, you know, additional living quarters. And you can imagine, you know, if you were in this thing yourself, uh, if this was your only living quarter, was these seats, that would be pretty uncomfortable. So it's actually kind of a bit unrealistic, in my opinion, to imagine 14 people in this thing for you know, 180 days. It seems awfully cramped, but nevertheless, we'll give them that additional crew habitat space just so they're not quite so uncomfortable. All right, let's go ahead and close those doors back up. I just wanted to show what that looked like. Use a little bit of time warp to speed up the animation and turn off the APU. Okay, now we are too terribly far away from 30-minute mark, so I'm going to go ahead and wrap up this part of the video here. And when we come back, we'll talk about the next part of the planning phase, which is to figure out how to go from where we're at right now into low Earth orbit. And just one more time, the point of figuring this part out first was so that we could then know what heading to go to. Because if we just take off and get into orbit right now and fly the runway heading of 330, or if we take off and get into orbit and go to a heading of 90 degrees, right now, this very second, we have no idea if we're going to be in the right orbital plane to go to Mars. We could be so far off that we would never be able to get there, because we could burn all of our fuel just trying to do plane change adjustments, and that wouldn't work. Okay, if you like this part of the video, like it, and if you didn't like it, hit the thumbs down link, that's no problem. More importantly, leave comments down below in the comments area. If you have questions specific to this video, please leave those questions below. I answer every question that's given to me. And check for links in the description of this video. And I will see you in the next part. Glider, by the way, that's absolutely fine. You can use the standard Delta glider and you can follow along with this and you'll have no problem. Just when we talk about turning on the APU and doing things like that, then you can just ignore those parts. But one thing to note about the XR2, and this would also apply to the XR5 and other vessels that have LOX, is that the default configuration, and that's what we're going to use here, we're not going to get into any kind of fancy you know, expert mode configurations, because this is the absolute beginner guide. But the default configuration, if I press Control down arrow, you'll notice that it only has 14 days of LOX. And obviously we cannot get to Mars in 14 days, at least not with. And once again, we are using the XR2 Ravenstar. As I stated in one of the previous videos, once you get to a certain level of comfort with Orbiter, you're probably going to find that the standard Delta glider doesn't really meet your space flight fantasy needs. It's a great vessel, but you know, because it doesn't have LOX, because it doesn't have APU and these types of things, the simulation can kind of feel a little generic. So the XR2 helps us spice things up a little bit. Now, speaking of the XR2, now if you want to do this with the Delta, learning how to go to the other planets using TransX, but if you don't already have that fundamental understanding of how to navigate TransX, then this is going to be too difficult for you. I'm making this video with the assumption that you have watched those other videos, so if you just tune into this one, and you might not be able to follow along, because I'm going, you know, again, I'm assuming you saw the other videos, so I'm not going to explain things in the level of depth that I did when we did those other videos. So we're going to learn how to go to Mars, and yeah, let's go ahead and get started. Let me switch camera views here. Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my absolute beginner guide, the video series I'm putting together that has a special focus on people who are brand new to Orbiter. In this section of the absolute beginner guide, we're spending a lot of time trying to learn how to use TransX. In the last several videos, we started off by going from the Earth out to the moon. I think we did that a couple of times. And then we did a return trip. We learned how to use TransX to go from the moon back to the Earth. Now, it is very important that you have seen those videos so that you have the base familiarity with TransX. We're now going to start with not in any sense of that's realistic. So one of the first things we want to do, or one of the first things we want to make a note of, is that we are going to require more locks than that. So just keep that in the back of your mind. And once we get into the actual setup of going to Mars, then we'll determine how much locks we need to carry. But just right from the start, know that you don't want to take off with only 14 days. Okay, now let's go ahead and switch cockpit views over to the larger MFDs. And we're going to bring up TransX on both sides like we usually do. And one thing